Good evening and welcome back to the video lecture series at BISAC by GTU. Here we are again going to see Basic of Engineering. Myself, Satyam Chauhan from Atmiya Institute of Technology and Science, Rajkot. So in Basic of Engineering drawing, we approach to the almost final chapter, that is isometric drawing. So today we are going to see basics of isometric drawings, basic shapes, and some theory related to isometric drawing, like what is the isometric view and what are the isometric projections, etc. So we are going to discuss what is isometric drawing and how we are going to do isometric drawing and why it is necessary in basic of engineering drawing. So before starting any presentation, I would like to highlight some views about isometric drawing. So what is isometric? Isometric means iso means equal and metric means all sides. So basically isometric drawing means it says equal in all sides. So basically in engineering drawing we are going to discuss the isometric drawing, why isometric drawing is required. So in production drawing, or let us say in engineering drawing, isometric drawing is required to show the 3D dimension. We know that orthographic projection. So orthographic projection, it represent the front view, side view and top view. So it is basically a linear dimensional in one way only. So in isometric drawing we show the drawings, the object in 3 dimensions, so that producer or the interpreter of that drawing can identify that object will look like that. So isometric drawing, by looking at isometric drawing, one can easily understand the shape and the size of that drawing or of that object. Especially in assembly drawings, isometric drawing is very useful, where there are more than one components are available and there are lots of drawings on the drawings available. So on the assembly drawing, it is helpful, the isometric drawings is helpful to visualize the object, so one can easily see the design and easily can interpret the components of that assembly. Let us see what are the basic shapes and how to do the isometric drawing. For example, from orthographic to isometric. In orthographic, usually 2 views are given and the basically figure is given, that is isometric drawing. So in isometric it is reverse, that we are given orthographic views and we draw the isometric on the orthograph from the isometric orthographic views. So we have to interpret the individual orthographic views and then we have to produce the isometric drawing. Let us see how to produce that. So in isometric drawing, basically it is a typical pictorial projection in which 3 dimensions of an objects are shown in one view, and then if required the actual size can be measured directly from it. So it is basically representation of 3-dimension object. So in a typical condition, in the 3D drawing of an object, all 3-dimensional axes are mentioned equal inclination with each other. So in isometric it will be a 120-degree angle formed by 2 lines, and whatever drawing we are going to produce will be produced in between 120 angle. So basically in isometric it's a 3D drawing and it can be drawn in numerous way as showing below. 3-dimensional drawings, or say photographic or say pictorial drawing, here no specification relation among L, H and D. So there are 3 axes is mentioned. So one axis is for linear, the second axis is for dimensional, that is say let's say its width, and third axis represent height. So it is basically 3 dimension. So if I represent three axes with my hand. It will be the linear axis, the width and the height. So it will be look like in three-dimensional a box, a cube. So it is represented by a cube. Let us say this is D, L and H, that is L and D, this is D and L. So our top view is D and L, our front view will be L and H on this plane, and our side view will be D and H. So this will be the side view. Another pictorial view will be looking like this. So now observe the below given drawing, and one can note the specific inclination among the H, L and D axis. So iso means same and or similar or equal. Here one can find equal inclination among H, L, D axis. So each 120 degree inclined with each other, and hence it is called isometric degree. So any angle is 120 degree. So here we have cube which is formed by D, L and H axis. So the purpose of isometric drawing is to understand all the required size, shape and appearance of that object. So basically isometric drawing, we have this many parameters: isometric axis, isometric lines and isometric planes. So the three lines, let's say AL, AD and AH, meeting at point A. So all the three lines are meeting in point A and making 120 degree with each other, and hence they are termed as isometric axis. So here AL, AD and AH, these lines are called isometric axis. The line parallel to this axis are called isometric lines. So all the lines which are parallel to this line, let us say this line or this line, any line parallel to this axis will be called isometric lines. The planes representing the faces of that cube as well as the other planes parallel to these planes are called isometric planes. So the faces means DAL face 1, this will be top view, DAH will be the side view, or say DAL will be this plane will be front view. So all the planes are perpendicular to each other and this will be called isometric planes. Now some important terms. Let us first understand what is isometric scale. When one holds the object in such a way that all three dimensions are visible, then in the process of all dimensions become proportionally inclined to the observer's eye, and hence apparent in length. So basically isometric scale is a reduction. Let us say this reduction is 9 by 11, approximately 0.815. So we are reducing the object from 11 part to 9 part. That is called isometric scale, and it will be approximately 0.815. So in isometric, the actual size will be reduced to the 0.815 times to the actual size. So that is isometric scale, and hence to draw isometric drawing is called isometric scale. In practice, while drawing isometric projection, it is necessary to convert the true lengths into the isometric lengths for measuring and marking the sizes. This is conveniently done by constructing an isometric scale as per described on the next image. So here is the main difference between isometric view and isometric projection. It is very important to know that what is the basic difference. So here, as we learned from the isometric scale, this will be the true length. Let us say it is from A to D will be 0, 1, 2, 3 and 4 segments. So this will be the true length. It is, we know from the orthographic projection that any length drawn at the 45 degree gives us a true length. For example, by rotating the plane. And so from iso length, that means isometric lengths are drawn in 30 degree. So if we draw a perpendicular line, let us say projection from these points, and the exact points on the 30 degree line will give us the isometric lengths. So this part will be 11 segment and this will be reduced to the 9 segments. So this will be the reduced isometric length and it is called the isometric length. Hence, in orthographic view, it is drawn by using true scale, and in isometric projection, it is drawn by using isometric scale. It means by using reduced dimension. So from construction point of view, from point A with line AB, let us draw first 30 degree line and 45 degree line inclined and give name as AC and AD, and mark the division of the true length, let us say 0, 1, 2, 3 and 4. Each division draw vertical line up to AC. So let us from 1 and 2, 2, 3 and 3, 4 and 4. So the division thus obtained on the AC gives a length on the isometric scale. So we can use to draw isometric projection, we can use this length, and hence it's called reduced dimension. So these are the types of isometric drawings. To draw isometric view, we are using true means actual dimension, the dimension exactly given in the problem. We can use them in any axis by simply drawing in 120 degree angle. And in isometric projection, we have to take the lengths from here, and hence it is reduced size. So we can see in the picture that the size in isometric view is actual size, while the size in the isometric projection looks reduced. So this is the basic difference between the isometric view and isometric projection. Let us move further, and now we are going to see the isometric of a plane figures. Let us see some geometrics, and first of all let us understand the basic theory. As this all 2D figures requires only 2 isometric axes, so we have to learn from first that what are the basic shapes. So for example, rectangle is represented by ABCD, has no width, so this is just a plane. So as this all figures 2D figure required only 2 isometric axes, if the figure is front view, so H and L axes are required. So right now we are not using the third D axis, so we are drawing only front view and top view. So if the figure is top view, D and L axes are required. So we can see the D axis in only front view. Let us understand by drawing its isometric views. So isometric view, if the shape is front view or top view. So let us draw first basic shapes, front view and then top view. So to draw front view, we required H and L. So L will give us the length. So by drawing two lines, that is H and L, H is as usual 90 degree to the baseline and L will be 30 degree. Hence it is isometric axis. So by drawing the same length, we can produce the front view A, B, C, D. So here C and D are on this same distance as B to C. So same distance as B to C. Here we got the isometric front view, and hence we know that from to watch the top view, we required D and L axis. So D and L will give us the top view. So hence the A will be on D axis. So A, B, C and D will give us the isometric top view. So if there is no thickness, a simply 2D figure we can produce in isometric by drawing front view and top view. It is very important to understand the basic shapes and how to produce the isometric. In complex drawing, we frequently see these shapes. So these shapes are important to understand that how to draw isometric of this shape. The second one is triangle, has three sides represented by 1, 2 and 3. So let us draw a rectangle and let us say the 3 will be the bisect of A and B. So it will be easy to draw the isometric of a triangle, and then draw H and L axis, the isometric axis, to show the isometric first view, front view of the triangle. Let us draw first